Hello everyone and welcome back to my channel. In this video we are going to see insertion sorts algorithm with the help of an example, right? So on your screen you are now seeing the algorithm for insertion sort, and in order to understand this particular algorithm, let us take an example, right? So I have an unsorted array with following numbers, right? Let's say these are the numbers that are there in the unsorted array, and let the indexing value starts from 1, right? So I have 6 unsorted elements over here. Now taking the first step of my insertion sort, which says that you need to take a for loop which is starting from 2 and going till the length of your array, right? So before actually getting into solving this particular example, we need to know something important about insertion sort. Now insertion sort actually divides your array into 2 parts, right? One part is the sorted part, right? And other one is the unsorted part, right? So it divides your array into 2 portions. Over here, if I consider as per this for loop, you can see that the for loop is starting from index number 2, right? That means it is not considering the first index of your array. Why? Because it is taking the first element of your unsorted array as trivially sorted, right? So because it actually acts as how we actually solve the sorted cards, right? How we sort the playing cards, right? So insertion sort works as the playing cards. So if you have drawn only one card, that means that that particular card is trivially sorted because it do not have any other card to get compared with, right? So it is taking 9 as sorted, and here the for loop is going to start from 2 to the length of the array, right? So this portion is the sorted portion and this portion is taken as the unsorted portion, right? So variable j is going to be placed over here. Now step number 2, which says key is equals to aj. Now key will be a variable that will be holding the next unsorted element. At this point of time, that value will be 6. So what key is going to have? Key is going to have 6 in it, right? And now the task of insertion sort is to insert this aj into the sorted portion, right? And in order to keep track of the sorted portion, I need a variable. Let's say the variable name is I, and I is set at j minus 1, that is just before j. That is just at the immediate left of j, that is j minus 1. So in this particular case, the value of I will be equal to 1. Now, the main important essence of insertion sort is step number 5, 6, 7 and 8. Now this step number 5 is actually meant for the comparison, because insertion sort is a comparison based searching technique. So why this comparison is to be done? See, we need to place 6 in the sorted portion, right? We need to place 6 over here, right? So now 6 is going to get compared with the immediate left element, that is 9, right? So if ai, that is 9, is greater than key, so if 9 is greater than 6, what is to be done? We need to swap this. What we need to do? We need to swap this. So what we are doing? We are comparing these two values, and you can see that 6 is not at its correct position. It should be placed before 9, right? So now what we are going to do? We are going to swap these two elements, and the answer will be 6, 9, and the rest of the array as it is, right? Now this is the main working of insertion sort, and now the partition will be over here. In the next iteration, the value of key will be equal to 5, and again because j is now incremented from 2 to 3, right? So at j, the value is 5. Now 5 is going to get compared with 9. Then it is of course not at its correct position. Then 5 is going to get compared by 6. Yes, 5 is less than 6. So the next answer will be 5, 6, 9 and rest of the array as it is. And now the partition will be over here. Again, same is with the case with 0. Now key becomes 0 and I is at immediate left, right? You're going to compare it with 9, then I get decremented again with 6, again with 5, and you get to know that the answer should be something like this. And now the division will be over here. Same, now you're going to compare 2 with 9, with 6, with 5, and on comparison with 0, you get to know that the array should be something like this. And now the partition will be here. Now in the last iteration, key will be 8, it will be compared with 9, it will be compared with 6, and then you can get the exact position of 8. Now that is how we actually solve the questions using insertion sort. So you can see it very well that step number 5, 6 and 7 are the essence of insertion sort. So that is how we are actually solving this particular question. But something important is there when we do the analysis of insertion sort. So for doing the analysis of insertion sort, let us consider these particular examples. What I have done over here, this is the same algorithm as we have seen before, but I have labeled each and every step with a cost, right? So what is C1? C1 is the cost of one-time execution of step number 1. Similarly, C2 is the one-time execution of step number 2, and similarly for all other up till C8. So what we are going to do over here is we are going to actually calculate that during the execution how many times each step is going to actually run. So talking about step number 1. See, step number 1 is going from 2 to length of my array, right? That is, it is going to get true up till n minus 1 times. See, if I have n number of elements in my array, I have not included 1 over here. So how many times it is getting actually true? It is getting true at n minus 1 times. That means it is actually executing till n times. See, n minus 1 time the for loop is getting true, right? And plus 1 times it is actually getting evaluated, because when the value exceeded the length of the array, only then you are going to say that for loop is actually getting false, right? So n times it is getting true, and 1 plus condition, because at that point of time it is also going to evaluate step number 1, but it will not going to enter into the loop, right? So it is going to evaluate, let's say, n times. Similarly, step number 2, it is inside the for loop. So we can say that it is getting executed n minus 1 times. Similarly, this is also inside the for loop, so it is also going to execute n minus 1 time. Same with this particular step, n minus 1 time, and this step, that is C8, n minus 1 time. But now we need to check about the step number 5, 6 and 7. This is inside the for loop, inside the while loop actually. So we need to actually consider it, separately for different cases. Now let us say that j is going from 2, 3, 4, let's say up till n times, right? Now let us say that this while loop is executing t 2 times for j is equals to 2. Let it is executing t3 time for j is equals to 3, t4 times when j is equals to 4, and tn times when j is equals to n. Therefore, we can say that the total execution of while loop is nothing but the summation of this particular value. So we can say that the while loop is executing from summation j is equals to 2 to n, and let me termed as tj, right? So we can say that this is executing summation t j times, where j is equals to 2 to n. Now talking about step number 6 and 7. Now this is inside the while loop, right? So as we have seen that if for loop is executing n times, then inside it is executing n minus 1 time. So we can say that step number 6 and 7 are executing tj whole minus 1 time, because it is inside the while loop, right? The while loop will execute one extra time, right, in order to check the condition whether it is true or false. As soon as it becomes false, we do not get enter into the while loop, right? So we can say that these two steps are executing summation tj whole minus 1 from j is equals to 2 to n, right? So with this particular analysis, what we understand? We understand that the total time complexity, that is the general equation of total time complexity of insertion sort, the general equation is equal to, see, cost of one execution is C1, then cost of n execution will be Cn multiplied by n plus C2 multiplied by n minus 1 plus C3 multiplied by n minus 1 plus C4 multiplied by n minus 1 plus C5 multiplied by tj, right, plus C6 multiplied by tj minus 1 plus C7 multiplied by tj minus 1, j is equals to 2 to n plus C8 n minus 1. Now this is nothing but the general equation of insertion sort. And over here, one more thing that I would like to tell is that the comments are never executed, right? So this particular value will become equal to 0 because they are never executed, right? So this is the general equation of insertion sort, and we need to calculate the value of tj in order to find out the time complexity of insertion sort, right? So because when we calculate the time complexity, it is always in terms of n, right? So we need to eliminate the value of tj and tj minus 1, and then we can conclude the value of analysis or the complexity of insertion sort. Now in order to understand the analysis, let us consider some of the questions, right? So let me just make a simple table of what we are actually doing over here. We are making comparisons and we are making swaps, right? We are making comparisons and we are making swaps in this particular algorithm. So talking about maximum comparison and minimum comparison, maximum swaps and minimum swap, right? So let us see that. Suppose if I have a array which is already sorted, right, which is already sorted. So we are going to divide it into two portions, right, and then we will be considering each element, right, say that 2, and then compare 2 with 1, right? But you can see that 1 is less than 2. That means 2 is it in correct position. So how many minimum comparisons are there? 1, but there is 0 swaps, right? And this is for j is equals to 2. Again for j is equals to 2. Now if I am over here now, then 3 will be compared by 2, and you can see that 3 is at its correct position. So minimum comparison is 1 and is 0 for j is equals to 3. Similarly, if I talk about 4, Now 4 will be get compared by 3, and you can conclude that 4 is at its correct position. So at j is equals to 4, the number of comparison is 1 and the swap is equals to 0. So you can see that if there are n numbers, right? If there are n numbers, then the j loop will go from 2 to n. That means the minimum comparison will be equal to n minus 1, right? And the minimum swap will be equal to 0, right? So for the best case, putting these value in this particular example, the value of tj is n minus 1, right? And the value of, see, you can see over here, the step number 5 is for comparison. See, I have written this over here. Step number 5 is for comparison and step number 6 is for swapping. And for the best case, we have seen that the total number of comparison is equal to n minus 1 and total number of swap is equals to 0. Therefore, substituting the values over here, we can write this particular statement as n minus 1 and these two statements become 0. So we can actually eliminate it from here, right? We do not require C6 and C7 over here, right? And now on solving this particular equation, you can see that you are going to get a linear equation, right? Therefore, in best case, the time complexity of insertion sort is actually equal to omega of n, right? Because there is only the dominant factor as n, right? Now considering the worst case scenario, consider the worst case. The worst case is reverse sorted, right? And let us see how many comparisons are there and how many swaps are there. For j is equals to 2, 3 and 4 for our example, right? So let us see how this actually goes. So the division will be something over here, and now 3 will get compared with 4, right? That means there is one comparison. And yes, it is to be swapped as well. So there is one swap. Now the division is over here. Now 2 is compared by 4, it is not correct. 2 is compared by 3, it is not correct. That means it requires 2 comparisons and 2 swaps. So once the swapping will be done between 2 and 4, so it will be something like this: 3, 2, 4, 1. And then 2 will be swapped with 3. That means it will be something like this. So 2 comparisons and 2 swap. And now the division will be something like this. And you can see that one comparison, another comparison, another comparison. There are 3 comparisons, right? And of course there will be 3 swaps only, right? So here you can see that how many times it is actually getting compared. It is getting compared by n minus 1 times, right? And how many swaps are there? Swaps are also n minus 1 times, up till n minus 1 times, right? So you can see that if I convert it into in form of a formula, so the total comparisons, right? So total comparisons when j is, let me say like this, j is 2, 3, 4 up till n, right? So if I say that if the series include 1 over here, it is the sum of the n natural number series. So it is n plus 1 whole divided by 2, right? But in this case, now this series is 1, 2, 3. This is 1, 2, 3, and it is going up till n minus 1, right? So this is going up till here. See, for 2 it is 1, for 3 it is 2, and for 4 it is 3. If total number of element is 4, then it is going till 3, right? If n is equals to 4, then it is going till n minus 1, right? So the series is this particular series. And we know that 1 plus 2 plus 3 plus 4, it is the sum of n natural numbers, right? But I need to calculate it till n minus 1, so I can subtract n from this, right? Because the series is something like this, n minus 1 plus n. Right? The series is like this. So n is getting subtracted from here. Correct? So the series will be n minus 1 whole divided by 2. On solving this, we get this particular relationship. So now on substituting the values again over here, all others are same, but in place of Tj, I will be writing n minus 1 whole divided by 2. Right? And for C6 and for C7, the value will be n minus 1 whole divided by 2 whole minus 1. n minus 1 whole minus 1. So now on solving this, you can see that the highest factor is n square. So for the worst case, you can see, for the worst case scenario, the time complexity is coming out to be quadratic. That means big O of n square. So that is how we actually did the analysis of insertion sort. So in the worst case, the time complexity is quadratic, and for the best case, the time complexity is linear. Right? So I hope that you understand this particular algorithm and its analysis. And for more such videos on the subject, stay tuned to my channel. Thank you.